Hello everyone. Today in our first video lesson, our topic is the free fall. Free fall is another example of an object which moves in a one dimension. The one example we have studied in the previous lesson that motion of an object either goes back or forward in the presence of the acceleration. The free fall is the motion of an object straight line while rising and as well as falling with the presence of acceleration of gravity. Let's just suppose that I throw the object with the initial speed of 30 meters per second to the air. In each second of its motion, object is going to decrease the velocity into 20 meters per second. In each second of motion, the object is going to drop the velocity by 10 meters per second. And then it becomes 10 meters per second, and then finally the object is going to have 0 meters per second velocity. When it has reached the maximum point at the motion, the object is going to start slowly falling down. First 10 meters per second, after 20 meters per second, and finally object will be landing on the ground with a velocity of 30 meters per second. So, in each period of the motion, the object moves 1 second and changing the velocity by 10 meters per second. This is because gravitational acceleration is equal to approximately 10 meters per second and per second. Which means that an object moving in the air changes the velocity in each second by 10 meters per second. And here you see the four basic formulas of accelerated motion in previous lessons we have studied. In this formulas, we are going to be replacing acceleration with the gravitational acceleration. The Lx also will be replaced by h, and also in the third formula, a is going to be replaced by g, and plus and minus sign will be added, and also delta x will be replaced by h, and here. Wherever you see acceleration, we are going to be replacing by the gravity, and wherever there is a displacement of an object, since object moves in a horizontal line, vertical line, the delta x will be replaced with h. So these are the four basic formulas of the free fall, which are slightly changed forms of the accelerated motion an object. Okay, let's go. In the next page, you will see this problem solving strategies. The first, it's very important to choose your positive and negative directions. Mostly, motion of an object going, this is the direction of gravity, direction of g. Mostly object rising up in the air, we are going to be choosing as negative, and object falling down, the direction we've chosen as positive. It's important to choose your zero level, and use all those old formulas I just showed you right now. We will be replacing acceleration by gravity. Okay, let's take a look at an example. A stone is dropped from 200 meters above the ground. Find the velocity and height after 5 seconds. So, here is my ground zero level, here is my own object. The object is going to start falling down. So, since stone is dropped, when you drop the object will have an initial velocity of 0. And I like to calculate the speed and height of an object after 5 seconds. And acceleration of gravity will be used approximately as 10 meters per second squared. My aim is to calculate the final velocity of an object. So there are different formulas we can choose and use in this example, but let's just use very simplest the formula which the final velocity of an object, initial velocity plus gravitational acceleration times the time. So final velocity of an object is going to be equal to v0 is going to be 0, because since object is dropped from the point, it's going to be 0. G is approximately 10 multiplied by time is equal to 5 seconds. So in this case, the final velocity of an object would be equal to 50 meters per second. Final velocity, and each second, remember the previous example, in each second of the motion, object in the air, it's gonna increase the velocity by 10 meters per second, which means that after 5 seconds, the object will have a velocity of 50 meters per second. Okay. Now, this was the first part of the problem to calculate the speed of an object in the air after 5 seconds. Here, let's just suppose that my object is located somewhere here and it has a velocity of 50 meters per second. Now, let's go back to question part B. I need to calculate height of an object after 5 seconds. So, I can use the formula A is equal to 1 over 2 V plus V0 multiplied by T. So, I know that the final velocity of an object after 5 seconds is 50 meters per second. Initial velocity is given as 0 because we just dropped the object, and the time is equal to 5 seconds. So in this case, 1 over 2, 50 plus 0 times 5. Then 50 plus 0 is going to be equal to 50 times 5 over 0. And the height of an object after 5 seconds would be equal to 125 meters from the ground level. So this is the height of an object. Basically, object is gonna be somewhere here, because this is the 125 meters after 5 seconds of the motion. Because we are going to be measuring height of an object from the ground level, so object has been moved actually the 75 meters in the air. That's it for this problem. Let's go to example 28 and look at another example. So in this example we have an object, we have a ball which is dropped from the top of the building, which is 20 meters high. 20 meters high, it's about a house which has 6 floors. So, part A. And when does the object start? So, I need to calculate the amount of time the object spends in the air to be able to reach the ground. So, what are knowns? I know that object is dropped, so the velocity initial will be equal to 0. I know how high the object is dropped, and I should be calculating t. So let's just check if I need any other information here. Time is asked, initial velocity is 0, h is 20. Okay. So the formula I'm gonna, and of course, gravitational acceleration will be used as again 10 meters per second squared. So my formula is gonna be, the formula I'm gonna use is equal to h is equal to v0t plus 1 over 2 g and t squared. Height of an object is equal to initial speed times amount of time the object spends in the air plus 1 over 2 gravitational acceleration and square of the amount of time. So height of an object is 20, v0 is 0, so this part of the equation goes to 0. 1 over 2 g is gonna be 10 and t squared. And in most of the children might be struggling to deal with these equations. So in order to simplify, I'm just gonna be dividing 10 by 2, which is gonna be 5t squared. 20 is gonna be equal to 5t squared. So basically 4 gonna be equal to t squared. Then t will be equal to 2 seconds. So object amount of time the object spends from 20 meters high to the ground, it's gonna be equal to just 2 seconds. That's not really a big amount of time the object spends to fall from 20 meters high. Okay, this was part A, now part B. What is the final speed of an object? So this is the easy question where we will use the basic formula of final velocity is equal to initial velocity plus gravitational acceleration multiplied by time. The final velocity is not known, where initial velocity is 0, gravitational acceleration is 10, and the amount of time the object spends in the air is 2 seconds. So basically, final velocity of an object would be equal to 20 meters per second. So if I drop an object from 20 meters high, from like 6th floor building, it's gonna be reaching the ground after 2 seconds, and then final velocity of an object would be equal to 20 meters per second. This was it for example number 28. And let's just take a look at this problem. This is gonna be our last example for this lesson. An object an object related from the rest height above the ground reached the ground with the 40 meters per second. Find the initial height of the object. So this object is dropped again from some height which we don't know how much, and the amount of the velocity of an object when it just strikes the ground wanna be equal to 20 meters per second. So let's just write down the equations and the knowns. I have known that the initial velocity is going to be 0 because when you drop from the rest, the object doesn't have initial velocity, and the final velocity is going to be equal to 20 meters per second, and gravitational acceleration is going to be equal to 10 meters per second squared. Okay, so to be able to calculate the height of an object, I might use a formula which is not containing time. So h is equal, this final velocity of square of final velocity of an object goes to square of initial velocity of an object plus 2 times g times h. Since we know the final velocity, initial velocity, and gravitational acceleration is constant, so that 4t squared would be equal to 0 squared plus 2 times 10 times height. So 4 squared is going to be equal to 1600, where 20 is going to be equal to 20h. So if 1000 is equal to 20h, nh would be equal to, nh would be equal to 80 meters. The height of an object which I drop and it's going to have a final velocity of 40 meters per second should be equal to 80 meters. So guys, this is the end of this first lesson. Hope to see you in further lessons. Goodbye.